Welcome everyone. In this video lecture, we will summarize some basic concept regarding the Op-Amp IC LM741, basically pin function, okay, and their configuration and important datasheet values for LM741. So we will go for some fundamental LM741 IC. So the very first IC we can say LM741H, which is basically a 8-pin transistor outline metal cap, 8 pin. Okay, 8 pins are there, but it is a metal cap, not the rectangular kind of IC. Okay, so this one is also one of the 8-pin transistor outline op-amp IC, which is metal can type, and where this is our through hole component package. So this one is also one op-amp IC. That's why we have put it this as a first IC. Okay, and as we know the pin configuration, so pin configuration is like we are starting from the one, so pin number one. Okay, so pin number one, this one is our pin number one, is our used for the offset null, and pin number five is also used for the offset null. Okay, pin number two, is our inverting input. Okay, then pin number three, is also in non-inverting input. Okay, so that we know. Next, pin number 4. So pin number 4 is our negative supply voltage. Okay, so pin number 4 is a negative supply voltage, and pin number 7, is a positive supply voltage, and 6 is our output. We are taking output, so 6 is the output pin, and 8 1, this 8 1 is our not connected. Okay, so this one is some top view. We can say the top view of a LM741H IC. Okay, this one is our metal can type of IC. So I have already written all the numbers. And LM74 IC can be used as a direct plug replacement. Instead of LM741 IC, we can use some different IC by direct plug-in replacement. If we replace some 741H IC and we can use the other IC, it will work very similar. It will work in a very similar nature. So these ICs are okay. So some fundamental IC like LM741 that we know, LM709, LM709C, LM201, MC1439, LM748, LM741C, and LM741A. So many ICs are there. So these are the IC. Okay, so this one is the first one is our metal can type. Okay, so first one is our metal can type op-amp. Okay, second one that we very much familiar, that is our rectangular, what we can say the uh, PDIP, plastic dual inline package, or sometimes we can say the ceramic dual inline package kind of IC, 8-pin IC. So this is also very fundamental. So as we know, this one is a offset null, two offset null, okay, 1 and 5, okay, which are used to eliminate the offset voltage. Okay, so these are the offset null terminal, and this one two number is our inverting input, already discussed non-inverting input. 4 1 is a negative supply, and 7 is a positive supply. 6 is the output, 6 is the output port, and 8 is the our what? It is our simple not connected or floating. So it is, we have to write it not connected pin. Okay, NC. 8 one is not connected. So LM741 IC is a 8-pin CDIP, okay, or PDIP, ceramic dual inline package or plastic dual inline package. So common type of IC packages, these are the common type of IC packages with a rectangular shape, and two rows of pin, two rows, one row, two rows of pin, allowing for through hole mounting on a circuit board or PC, on breadboard. Okay. Now some function. First we will discuss the some function in brief. So LM741 pin function. So first pin, we can say 1 and 5 pin, that is our offset null, is called as the input pin. So offset null pin is used to eliminate the offset voltages and balance the input voltages. So that can be used, yeah, offset null pin 1 and 5. Okay, the inverting input, second terminal, input port, inverting signal. We can give the inverting signal input through two input through second number of pin. Non-inverting terminal or input is our three number pin, input pin for non-inverting signal input. Four number negative supply. Okay, so four input negative supply, six outputs, which is we will get the amplified output signal from the six number pin. V plus is the seven, which is the input positive supply voltage. Okay, and eight is not connected, which is no connect and floating node, we can say. So this is simple our description for the pin configuration. Now we will go for the important data sheet. So actually we have to know some important data sheet values like for op-amp. So op-amp operate up to what voltages? So first one is our supply voltage. What is the range of the supply voltage for the LM741? So LM741 will work in between the range plus minus 10 volt to plus minus 25 volt. This one is the range. Okay, so typically we are mostly playing with this plus minus 15 volt. So typical range for the supply voltage for the LM741 is our plus minus 15 volts. So mainly we are taking plus minus 15 volt. Output voltage swing. So output voltage swing of a LM74 IC, we will generally get around plus minus 13 volt, which is less than the typical supply voltage. Okay, this is for the test condition plus minus 15 volt. And CMRR value, if anyone asks what is the CMRR value for the op-amp, so we can say 95 dB. Okay, 95 dB, or generally it will vary in between 80 dB to 95 dB. So you can say 95 dB is the common mode rejection ratio. And slew rate for an op-amp LM741, which is already given in the data sheet, is our 0.5 volt microsecond. Okay, and output short circuit current is 25 milliampere. Okay, these are the some important data sheet value which is given in the data sheet of OPM 741. So many things are there, but these are the important. So I'm just giving the summary of all this data sheet. And the input offset voltage will be plus minus 15 volt. So input offset voltage will be plus minus 15 volt. And the input impedance is very high. So input impedance range in between 0.3 mega ohm to 2 mega ohm, or sometimes we are saying 1 mega ohm. Okay, so input impedance, if you say in 1 mega ohm, it is also okay. Now next, output impedance. Output impedance is low, as we know. So the output impedance is in the range of ohm, so 75 ohm. At bandwidth, up to what frequency it will work? So it will mainly work up to 0.4375 megahertz to 1.5 megahertz. So we can say bandwidth, sometimes we can say 1 megahertz. Okay, so 1 megahertz, also we can say 1 megahertz bandwidth. Okay, because it will work in that range. So, and power consumption in case of LM741 IC is around 85 megawatt. Sorry, milliwatt, not mega. Sorry, milliwatt. So these are the some few fundamental, what we can say, the data sheet value which are already given in the uh, data sheet of an op-amp. So just I have summarized the all the data sheet value. So in addition to that, some other data sheet value are also available, like what we can say the uh, what we can say the differential input voltage range. Differential input voltage is in the range of plus minus 30 volt. Differential input voltage range. So differential input voltage in volt, it it is in between plus minus 30 30 volt. Okay, so in addition to that, some what we can say the rise time and overshoot. So suppose some signal is given, if we are giving some signal to the op amp. Okay, so the corresponding, this, if this one is our input, we can say this one is our input. So there will be some. Okay, so this is rise time. So that thing rise time is also given. It is around zero point 0.3 microsecond typically. In datasheet it is given, and the overshoot, this overshoot. So they have so many, and this overshoot value will be around 5%. Okay, for example, if this one is our 10 volt magnitude, okay, so this will be 0.5 volt. Okay, this should be, if I'm saying overshoot 5 volt, so this height will be around 0.5 volt overshoot. Okay, so overshoot slew rate, already discussed slew rate for a traditional 0.5 volt per microcontroller. How the output changes with the time. Okay, the rate the output change. So this one is also output impedance, already we have covered. CMRR 95 dB. Okay. In addition to that, input offset current. Okay, one more thing is left. So I am also writing input offset current. So input offset current range in the range of 20 nanoampere to 200 nanoampere range. Nanoampere range. Input offset current and common mode rejection ratio, already we have discussed. And one more thing is there, supply voltage rejection ratio. Supply voltage rejection ratio. High voltage rejection. It is also around 95 or 96 dB. So these are the some important, very important datasheet values for an OPAMP LM741 IC. One can directly ask what is the value for LM741 IC like CMRR. So we have to say 95 dB, it's okay. Then slew rate 0.5 volt microseconds. Okay, input impedance around 1 megahertz, 1 mega ohm. Output impedance 250, 75 ohm, bandwidth around 1.5 megahertz or 1 megahertz we can say, and supply voltage and plus minus 15 volt typically, and output voltage swing plus minus 13 volt like this. So this is all about a brief idea about the pin configuration and data sheet, and some one important this one, this LM741 metal can type op-amp, metal can type op-amp is also available. Okay, so this is the top view. So this is all we have covered, some fundamental basic that you know, but we have to know the some important data sheet value for LM741. So this is all about this lecture. So thank you for watching this video. Thank you.